at transformations of graphs, and we're going to look at 4 transformations of graphs, which is why I wrote down 4 things. And I wrote down the 4 things in function notation. So we're going to look a lot more with function notation coming up, mainly when we do operations with functions, but hopefully you've seen it before and have a small idea. Function notation is the f of x, and it reads f of x. It is not f times x. And it takes the place of the y. So if we have something like f of x equals 2x plus 6, we've seen this a lot more often with the y equals 2x plus 6. The reason we like function notation is it's easier to sub things in or insert things in. It's easier to work with. Instead of having a y equaling 2x plus 6 and then having a whole sentence that says, what is y when x is 7? I can instead just say, well, what is f of 7? F of 7 just means, hey, replace that x with a 7. What do I get if I sub in 7? So I would get 2 times 7 plus 6. And then I'd simplify, probably to get 20. Might as well finish that up, I guess. So that is the idea behind function notation. And you're going to start using that, well, from here on out, basically, through pre-calc, calc, things like that. Okay, so we're going to look, though, to see what happens when we change equations. How does that change graphs? So let's just go back to a graph that we've just drawn, 2 to the x. So we had f of x equals 2 to the x. Well, we had y equals 2 to the x on the other side. And we graphed it out. And when we graphed it out, we had that one point, because we subbed in points, we had that 1 point, 0, 1. And then as it went to the right, it shot up. And we're just sketching it. As it went to the left, it flattened out toward our asymptote. And our asymptote was on that x-axis. Okay, so we have this right now being our graph of 2 to the x. So let's see what would happen, and we're going to start kind of weird. So we're going to go in not the order it's written at all. But we're going to start with what would happen. Oh, we can. Okay, let's go in the order written. What would happen if we put a negative in front of it? So what would happen if we had f of x, instead of equaling 2 to the x, equaled negative 2 to the x? Well, let's go point by point and see what we think can happen. So if we go point by point, our first graph here, or our first point here is at 0, 1. Because we subbed in 0 for x, and we got y equals 1. Well, if I come over here and I do that here, if I sub in 0 for x, I'm going to get y equals, so 2 to the x will still be 1, but y equals negative 1. So I'm going to write out a set of points right here. Still my x, y. F of x I'm going to replace with the y. So I'll get 0 and negative 1. Because 2 to the x, 2 to 0 would still be 1, and it would have the negative in front of it. Okay, so that would actually be down here. What would happen this time if I put in 1 and 2? In the previous one, when I put in 1 and 2, it started rising up. If I put in 1, I got 2. If I put in 2, I got 4. If I do it this time, it's going to start going down. 2 to the 1 is still 2, a negative in front of it will make it negative 2. 2 to the 2 is still 4, a negative in front of it would make it negative 4. So instead of going up, it's going down. Okay, same thing would happen if I put in the negatives. Negative 1 and negative 2 got me 1/2 and 1/4. This time, it would be 1/2 but negative in front of it, and 1/4 but negative in front of it. So it would be negative, but still getting close and close to my x-axis. So I would still have the same horizontal asymptote. Okay, so what can we say about this? If I have a negative in front of the function, you see how this is in front of the function? It's not inside, so it was in front of my whole 2 to the x. If I have a negative in front of it, all I did was flip it upside down, right? So in math terms, we're going to say reflect over the x-axis. And we say reflect because it's like a mirror. It's a mirror image. So it just reflects straight over it. Okay, so let's see what happens if we do other things to this function. Say we have f of x plus 2. So this is going to match up with my number 2 up there. So let's see, I'll draw it out again. We have our standard. Our standard is still up here. It's that f of x equals 2 to the x. Now we're going to see what happens if we add 2. And this is called adding it inside the function. If we wrote it out with a 2 to the x, it would look like 2 to the x plus 2. Because the plus 2 is inside the function, it would stay inside the function. So let's see, what would happen if we went ahead and added the 2 inside the function? Well, again, we can do a chart. We can say x, y. And our chart's going to be a little different this time. If I put in 0, I'm not going to get 1. If I put in 0 this time, I'm going to get 2 to the 0 plus 2, so 2 to the 4. I'm sorry, 2 to the 2, so 4. Okay, if I put in 1, I'm going to get 2 to the 3, which is 8. That's already getting higher than we've ever gone. We've only ever gone up to 4. Let's put in some negatives. If I put in -1, then I would get 2 to the 1, which is 2. If I put in -2, I'd get 2 to 0, and now I'm back to that 1. That 0, 1 point that we saw in the last video was so important. Okay, if I put in 2 to -3, I'm at that 1/2 point, and if I put in 2 to -4, I'm at that 1/4 point. So at my y values, I still got all the same y values that I would have for 2 to the x, but they shifted. This time I didn't have 0, 1, I had -2, 1. I didn't have 1, 2, I had -1, 2. So they all shifted, and they all shifted to the left 2 spaces. So I have the same graph, but every single point shifted to the left 2 spaces. So if I'm adding something inside the function, it moves it on the x-axis, because it shifted it left to right, so that would be on the x-axis. And it goes in the opposite way. I was adding 2 here, so I shifted it to the negative side 2 spaces to kind of make up for the fact I was adding 2. So we're going to say -h spaces. Okay? So say I was going to have, and we're just going to write one up here, say I had 2 to the x minus 3, and I wanted to graph that, I would say, okay, this is going to shift it to the right 3 spaces, so the opposite way 3 spaces. So if I moved it, I would be moving my initial 2 to the x graph. I'd be moving that right 3 spaces, so it would end up over at 3. And then I'd try to recopy the entire graph. Okay, so let's look at the next one. So say I had f of x, let's do a plus just 1. So that would be 2 to the x, my function, f of x was just 2 to the x, plus 1. This is called adding outside the function. So let's see, if I graphed every point, if I sub in 0 this time, I'm going to get 2 to 0 is 1, plus 1 is 2. If I sub in 1, 2 to the 1 is 2, plus 1 is 3. If I sub in 2, I'd be up at 5, so every point should be up 1. If I sub in -1, I'd get 1/2 plus 1 is 1/2. -2, 1/4 plus 1 is 1 1/4. So every point should have shifted up 1 space. So if I'm adding outside the function, it moves on y-axis that many spaces. So if I'm adding 1, it moves up 1. Say if I want to graph 2 to the x minus 7, it would move down 7. Okay, last one. Say I am having a negative inside the function. What that would mean is I'd have a negative, you see how it's directly in front of my x there? I'd have a negative directly in front of my x term. So that's what inside the function means. Okay, so if I'm going to graph this, and again, I'm going to do it point by point just to show. So if I do 0, I'm still going to get that 1, because -0 is the same thing as 0, so 2 to 0 is still 1. If I put in 1 this time, I might as well go ahead and do a chart for the last one. So let's do a chart real quick. So 0 was still 1. If I put in 1, that'd be 2 to -1, so 1/2. 2 would give me my 1/4. So let's see, now I'm having it being 1 1/2, 2 1/4. So now it looks like it's going that way toward the asymptote. If I put in -1, 2 to -1 would be 2 to the 1, so 2. -2 should give me 4 then. So it looks like it's shooting up on the other side. So let's see, how did this one do? Well, when we had the negative outside the function, it reflected it over the x-axis. And it was kind of obvious, it kind of just popped upside down. Negative inside the x, it reflects it over the y-axis. This part here, this part that is to the left going toward the asymptote, flipped over and went to the right toward the asymptote. This part here that's going up and to the right, flipped over and went up to the left. So the whole thing just flipped over the y-axis. So it reflects over y-axis. And the order of the first and the last actually matter. When it's in front of the function, it actually flips over the x-axis first. You do that first before you do any other shifting. When it's inside the function, you flip it over the y-axis last after you've done all the other shifting. You could graph a bunch of these and kind of figure out why, but I'll leave that one to you. Okay, we'll look at more transformations next.